So the learning objectives for this lecture segment, we're going to be defining a thermodynamic standard state, explain why it's needed, calculating the enthalpy of reactions using Hess's law. Okay, so reactions that have a thermodynamic, we usually use a thermodynamic standard state. So we define this delta H degree sign, delta H standard state, enthalpy of reaction. We assume we're at 25 degrees C and 1 bar pressure. That's the standard state. And then we assume that all substances are in the most stable form, all solutions are at 1 molar. And then we measure the enthalpy of the reaction at this condition. Why does it, what's special about 25 degrees C, 1 bar pressure? It's really just a convention, because the key is once we have the enthalpy at one set of conditions, we can always calculate the change in enthalpy of the reaction at other states. Once we know the enthalpy of a reaction at one state, then we can calculate the delta H at other states, at other conditions. We can calculate the enthalpy of phase changes. These things can be measured, and we can include that as well. We have oxidation of hydrazine here happening at standard state, 25 degrees C, but you're not necessarily going to be burning hydrazine at 25 degrees C at one atmosphere pressure. You're going to be burning it like in a rocket ship. And so you can take the tabulated phase change, enthalpy of phase changes, and add that, and go through the calculations and find out what the enthalpy of the change to result in not a gas but a liquid. We can calculate the enthalpy of carrying out the reaction at a different temperature by with the heat capacity. We've seen that with the heat capacity we can calculate the enthalpy of those changes, so we can calculate the change in enthalpy to take the reactants to a new temperature and the products to a new temperature, include that as well. Pressure changes, the enthalpy of the solids or liquids doesn't change very much when we change the pressure. We can use the gas law for gas changes, and then we can total all those up. So once we have enthalpy, standard state of reactions, the standard state enthalpy of reactions, then we can calculate the enthalpy of reactions at other temperatures and other phases of matter. One I want to throw in there, that's a little in the book, but we should refresh a little bit more, is how do changes in state affect the enthalpy? You need to put some heat in to change phases, or take some heat out to change phases. If we have liquid water, then we need to add heat transfer into the system in order to go to a gas phase. Conversely, condensing is an exothermic process. Energy needs to be removed in the system via heat in order to get something to condense. So it takes a little practice thinking about this. For example, what if we have ice melting? If we're going from a solid to a liquid, well, for solid for a liquid, that's an endothermic process. And that sort of makes sense, because if you put ice on your hand, then it makes your hand cold. Why? Because it's transferring heat into the ice in order for it to melt.